intersect, it's an intersection of 3 planes. Underneath that, we'll also say intersection of 2 planes. Distance between lines. Distance line to plane, point to plane, plane and plane. What else? And plane, line and plane, plane and plane. What else? Converting from vector.
Oh, vectors. You have to do both vectors together.
Yeah.
Is that what you like? You keep it back together.
Give us a line. Okay, all of that's all that's on the test. And just to, Sam wasn't here when I announced it the first time, got it probably the second time. There are no real problems on this test. There isn't one.
Thank goodness.
Okay, so there you go. There's definitely a theoretical matrix. Beyond that, you could guess of what's going to be the rest of it.
How do you even do that?
A theoretical matrix? Yeah.
You just really know it next time.
Are we doing another one? Let's look at that for that. What else? Yeah, it's the same thing. If we're in bonuses before we're going, I saw 100 or something. 100? There's okay, just 4 questions all work the same. There you go, this is the way I do this test. 4 questions all work the same and the 5th one's worth half. So the test I like 45 or something like that, okay? Right? So
One part, like.
yeah, so it's like 10, that's one of that. Okay, what type of question do you want to go through? Do you want me to do that question or does this get first? Yeah. Depends on what you know. Like, what do you, when you have a question, find a board that will yeah, let's see the distance between, what do you want to do the distance between? I don't know, skew lines are always hard for people. Okay, let's say the skew lines here in a second. Simple one. Find distance between a line through the points pause and let you guys, I'll talk you guys through it and then I'll give you guys a chance to do it. Okay? How do you find the distance between skew lines? So you guys left to right. Nope. Well, maybe. I thought it was between one skew lines. What do you mean? You know, how do you get a normal? How do you get a normal? Cross the two direction vectors. Okay. The issue I have, I don't see a direction vector for the first line. Oh, that's true. Okay, so the first thing you do is make the normal, then you project. You pick a point on either line and make a vector and project it onto the normal. Okay. Good. Good. Killer, I'm moving you right up front right here. Stay with me, boys. No, seriously, Killer, move. No, let's do a test. Try to go through this as quickly as humanly possible so I can do this here. So I'll start with my normal. First I'm going to start with step number 1 is going to be find vector form for first line. Yeah. Okay, so then it's going to be here. I lost my pen. Okay. I'm going to say, okay. I'm going to call this A and this B. So I'm going to say that AB is 8 minus 4, 0 minus 3, and 6 minus -1. So vector AB is equal to 4, -3, and 7. Therefore, my first equation is going to be, we'll say W. Okay, there's my first vector now. Now, if you choose a different point, that's fine. If your direction vector is a little different, that's fine. That's the thing with this. You can use infinite number of ways to do this. Okay. Letter number 2, this in green, is going to say, find your normal. Between the direction vectors. Okay, so this is going to be S cross T. We have, what's my direction vector? 4. I'm just putting out a -1. Now, it doesn't really matter which way you do it because T cross S is just going to be negative. Right? And remember, you can multiply or divide by anything you want. So this is going to be 42I minus 8J plus 3K minus 6I plus 7. All right? So minus 6I plus 7. Okay.
Oh,
Is that right? You good?
You're good.
Okay, so my N is going to be 32 minus 6 is 36, -1 and -21. Does that look right? Are most people close to that? On the normal? Okay, so there's my normal. Number 3. The distance, whoa, goodness. Wait. All right, number 3 is going to be the projection. What was that called? P on that. Always people. Oh, they didn't pick the yet. That's funny. Oops, I didn't actually pick the yet. Let's see a check. This should actually be number 4. Whoops. Yeah, I think I missed a step here, so I'm working too fast. It's actually step number 4. Step number 3 should be pick. Yeah. 3 is going to be find vector P. Connecting both lines. So I pick one point off each line. The point I'm going to pick is 4, 3, -1, and 2, 1, 4. Now, if you chose a different vector P, that's okay, and that's the difficulty here. What I just did was I picked one point from each line, okay? So vector P is going to be 2, 2 and negative 5. Then I want to project P onto N. If you chose a different vector P, that's okay. All right, you'll still get the same answer. If you chose a different normal, that's okay. You'll still get the same answer. The final answer will match in between steps, not necessarily. Yes.
For P, like what do you mean there?
That's I'm picking 1 point off each line. Right. So this is 1 point from each line.
Does it matter which line is which? Like when you've done like few lines.
Yeah, definitely. Right. Just the only difference between the line is the one like a negative. Yeah. That. So this is where this is supposed to be tailored. Where you pick 1 point off each line, and that was exactly what that was. That was. We call it everyone. I have to call it. Okay. P dot N is going to be now. One more time here. 2 times 36. Plus 2 times negative 1, plus negative 5, and negative 21, all over 4. Okay with that? I hope. Why is the because I've never even read it. Right? That is actually going to be an actual vector, a Cartesian vector. Right? So I will eventually, I'm going to find it out. Remember. Now, the magnitude means distance, right? So it's going to be distance. So this is so this is going to be the magnitude of 72 minus 2 plus 105 all over, somebody's a denominator for me. 7038. This is 175 and 1738. Break down. Hope those. Divided by 3 by any chance? No. Alright. Time to keep going here. The question on your test will be significantly smaller than this. 1735 times 36. I can't do this. 6300. Someone just confirm those numbers for me before I just discover it. Alright? So we're good?
I did it wrong. Like I made a little mistake. I instead of putting in a negative 2, I just put a positive 2.
Wow.
But I still did the same process. Going back to the line, right?
Yes.
Do the numbers each other have to be.
Yeah. It's with 1 point from each line, right? So,
Yeah.
it can be anywhere, and as long as it's on, it's not anywhere, but it has to be on the lines, right? So, yeah, any of it on the line.
I got it. The last one was down to 174.8.
Okay, I'm going to leave it
Yeah.
ready now because the question was, this probably will, but I'm going to leave it so it's for everything that's a lot easier for the denominator, is what I'm saying. So it's going to be the square root of. The nice thing is everything's over 1738. Okay, negatives. Okay, John, please tell me this works out. Thanks. On your test, the numbers will be under 100. Okay, so don't worry. All right. No, they will be okay. So, if you're like Rob and you need your calculator home. Remember, was it Albert last semester tried to do the whole year without a calculator in your class, John?
Yes.
So they hated me as a teacher. What is that word? I can't actually do it in my head. It's way too big. Anyone get a square with that thing? I didn't go up the top there, did I?
Not yet.
Just the top or the
Well, the thing is because the bottom is going to be 1738 squared and the square of that. So that's 1738. Can you do 1600 squared plus 175 squared plus 360? What we got? Big number. 175, exactly. Beautiful. 300 squared plus 1600 squared plus 1. Alright, let's write up this line. Times 1738, times 1738, please. Times 1738. One square, one square. Whoa. You don't divide it in number.
Okay, you like a straight number, about 150.
Yeah.
You like square all and then divide it by 3.
Yes. What do you like ask? Okay. For this one, I'm sure I can report one more time. On your test will be nice numbers, not much smaller numbers. Okay, I'm going to do your question, and then we're going to keep going here, okay, hopefully. All right. Question number 2 is, this is Tuesday on the assignment. Find the scalar equation of the plane that passes through the point and is parallel to the plane y plus z equals 5. If, there's a few different ways you can do this. There's a few different ways you can do this. All right. First way to do this is 2 planes are parallel if they're the same normal. Right? So what we're going to say is 2. Okay. Without that, it's going to make this question more difficult. Because without that information, what you would have to do is you would have to take that y plus z minus 5, make 3 points out of it, and then you convert it into like scalar form, and you get your direction vectors, and then use that as your point, and then use 2 direction vectors to make your point. Right? That's the long way to do it. The short way to do it is to say that 2 planes are parallel with the same normal. What is, for the class here, what is a normal of x plus y plus z equals 5? What is the normal for that? Oh, this is going to be a higher test tomorrow. Yes. So my normal is equal to 0, 1, 1.
Yes. If it's parallel, that's usually 0, 1.
Yeah, that works out.
Yeah.
Okay, so 0, 1, 1. So here's how it goes here. So my equation is going to look something like this. 0x plus y plus z plus d is equal to 0. That's it in there. So what do I plug in to get d? What do I plug in to get d?
You can do 0, 0, 7.
What's that? That has nothing to do with the normal, right? That's why it's parallel, right? Because it's just a different number. So the normals are going to be the same.
With the scalar one, how do you know the line of
That That's a good question. Because that should, if you're going to look at that is actually what was supposed to be, right? Basically, it's going to be a plane, let's try again. It's going to be the equation of a plane because it's in scalar form. The reason that we can deal with that in 2 dimensions, all that happens is your Z would be infinite, right? So if you think of your graphing, if you're graphing on a paper, y equals x, like this, the actual rate infinite moves that direction too. Right, so it would be actually your line like this, y equals x. It would actually zoom out like this too with the z. Okay, so you don't actually look at that. So this is a plane.
Then what is the line?
The line, there's no scalar with the line. There's only 10 dimension vector of the line. In 3 dimensions. Yeah, no, this is 3 dimensions, right? That's the way to go. You want to move to 3 dimensions, right? This is 3 dimensions. There is no scalar vertical line in 3 dimensions.
Things are all the same. Is that like, you figured that out?
That's a fact. That's a fact. That's a fact. I totally yes.
It's also like,
If 2 planes are parallel, they're the same normal. 2 planes are the same normal, but parallel. Yeah, so that's what I was saying too. If you didn't remember that fact, you could have converted this to scalar form, or converted this to vector form, and made it 2 direction vectors. Right? Yes. So once you do 2 direction vectors, the same, you pick a point, and then you can do it constantly get back.
okay, so you turn that back into a vector.
If you want, yeah, what you can do is you can turn this into, yeah, you can turn this into vector form, pick different y's and z's and whatnot,
That.
and your normal that's going to be 0, 1, 1.
So we just make the parallel.
If the 2 planes are parallel, like if that's the case, if you're looking at this, look at this kind of this case. Yes. Yeah, if you want to do much of it, right? This will save you a lot of time here. The question was, can you always get the normal from the scale equation? Yes, you can. Remember, it's coefficients, A, B, and C is going to be a normal, right, from your scale form. And in the same way, right, and that's when you go from scalar forms, or from vector form to scalar form, right? So what you do is you just cross the normals, and that give you cross the direction vectors, to give you that's a good quote. Now we're done. So the book here mentioned we do it or by the board. Yes. Do we do these on Friday? Yes, we yes. Okay. Well, that's one entrance.